Hello student. Today let's we derive an expression for the growth of current in the circuit. L stand for the inductance and R stand for the resistance. You are seeing here the R inductance and R is connected series through the key to the battery. When we connect this battery, the voltage is flows through the inductance and voltage through the resistance. So then the supplied voltage is equal to the sum of the voltage through the inductance and voltage through the resistance. Then the net EMF is given by E equal to V, the voltage across L plus the voltage across resistance R. By the definition, the voltage VL is given by L into di by dt, and the voltage across VR is given by the Ohm's law, that is IR. So let it be, the equation is 1. When the current, the charge is going on, the current reaches maximum, then I changes to I naught and become constant. The current is there. When we charges is there, then the current flows through the rises and become constant. So then di by dt is become 0. Hence then from equation 1, then v becomes, this term becomes 0. Then e equal to e naught, e equal to I naught by r. Then put this value in equation 1. I naught r is equal to L into di by dr and IR. Then on simplification, that's the I naught R is equal to L into di by dr. Then take an R that side, R, that is I naught, I come to this side, I come to this side, that is I naught by minus I. Then L into di by dt remain. Then just interchange this value. This value goes to this one and dt here, that is di by I naught minus I equal to R by L into dt. Let it be equation 2. Then integrate both these equations. We will get, this is I naught, that is assume that x. Then integration of 1 by x is log x, that is log I x is I naught y, but I is there, that's why it is minus sign. And r by L differentiate with respect to t dt, that is r by L dt plus c, where c is the constant. For calculate the value of constant here, when time is 0, the current is also 0. Then the c changes to log I naught. This time is 0, this time is 0, then c changes to minus log I. Put this equation 4 in 3, putting the value of c, then we simply write down minus log I naught r by L t minus log I naught. Here is the minus symbol is there, that's why it is multiplied with minus. Then gives the all minus changes plus, here is changes to minus, minus changes to plus. Then this value is come to this side, then log I naught minus I minus log I naught minus RL by T. This is log M m log n. Log m minus log n is nothing but log m by n. That's why it is log I naught by I and I naught, and this right side remains same, minus r l t. When we log is set to this side, then log changes to exponent. E stand for exponent, that is e to the power of minus r by l. And this simplified right side, I naught get cancelled, 1 minus I by I naught, e to the power of minus rl. On simplification, we can get I equal to I naught into 1 into e to the power of minus rl. This is the equation for current grows in a LR circuit. I equal to I naught into 1 minus e to the power of minus. So the current in the LR circuit can be given by I is equal to I naught 1 minus e to the power of RL. Let's say study the equation 5 in some cases. If t is 0, then I is tends to 0. When t is infinity, then I tends to maximum. So, and this can be written as in the graph t versus this is t versus current. The current rises as the time increases. After some time, it goes to constant up to infinity. So this is the maximum current, that is I naught. So it is the ratio of the inductance and resistance is called time constant. This thing, and put this value tau is equal to, that is time constant t. Then the value I is changes to I naught 1 minus e to the power of minus 1 is a tau, t get cancelled. When this value reduces to maximum of 0.632, that is time constant can be defined as the time required by the current to reach the 63.2% of its maximum current. That is called a time constant. In time constant, you will see that tau is equal to L by R. This is time constant for the LR circuit, and this reaches the maximum current when t raises to tau equal to 5 tau, means 5 into L by R. Then it reaches to a maximum current and becomes constant. And this is the expression for current in LR circuit. And L by R is called tau, the inverse of this R by L, that is L by R. This is all about the growth of current in LR circuit. Okay, thank you.